Yes, welcome back regarding chapter number 13. Simple pendulum was left, so we are going to do that topic today, simple pendulum. Simple pendulum, what is simple pendulum? It's a mechanical system, right? That consists of a small ball or ball of mass m connected with a light string. Light string means the mass of the string or the thread is negligibly small as compared to the mass of the object. Now, what is L? L is the length of the pendulum from this hook up to the center of the ball. Right. This is the angle theta it makes while having simple harmonic motion. You see, when this is at rest position, this is its equilibrium position here, right? Once you disturb it from its equilibrium position to either side, say on the right side here, and then you release it, what will happen? It will go back to its equilibrium position. Due to what? Due to a force. We call it the restoring force. You remember we did in mass spring system also. And it is not just weight mg, but a part of it. How? This is mg, this is theta, this is mg sine theta. If you keep in your mind the basic head to tail rule, adding the two vectors, okay, this is this component, x component, this is its y component. I mean, in front of this theta you have sine component. So this is parallel to this, so I take this one, which is mg sine theta. This is the restoring force for the simple pendulum, which causes this pendulum to move in simple harmonic motion. Right, again, once it reaches this point, it will go back due to, the restoring force again. And once it reaches this point, due to inertia, it moves to this side or this side where it is going on. Now, you see, you have the restoring force we have minus kx. This is what we learned from mass spring system. You remember? All right. Now, when you have this much, so this is restoring force, as I told you, is mg sine theta. Mg sine theta, of course, minus. Okay? So minus goes with minus. Once you have, we need this to be linear, but if you have greater angles, it will be almost like this arc. So if you need it to be linear almost, this s or x, you need this to be very small. So 10 or 15 degree will be enough. So for these small angles, you'll be having simple harmonic motion. So when you have small angles, sine theta is equal to theta, right? So sine theta is equal to theta, kx. You see, we have another relationship. You finish, s is equal to r theta. What is r? R is the L here. Okay? So SRX is L theta. So in place of x, I would write L theta. K mg theta. Theta goes with theta, and you have k is equal to mg over L. Right? Now we have omega is equal to K over M under the root. Now K is mg over L for mg over L over this M. M goes with M, and you are left with omega is equal to G over L under the root. So omega is equal to G over L under the root. Now we have the time period, which is time for one vibration, 2 pi by omega. 2 pi. Omega is equal to G over L under the root, but you need 1 by omega, so it will be L over G. So this is the time period for simple pendulum. L is the length of the pendulum, right? This is length of the pendulum, okay? And G is the acceleration due to gravity. By the way, you can find out, sometimes you'll be asked to find out, you know, the acceleration due to gravity G due to at any location. For example, this is the rule we just finished. T is equal to 2 pi L over G. You need G now. I am going to square both sides. Okay. Now, I need G. I take G to the left and T square here in the denominator. So G will be equal to 4 pi square L over T square. This is the rule for finding G at any location. We would use this rule in solving this last example of this chapter. After that, you will find on my YouTube or video series your tutorial, shall assume. Don't worry. Okay, using a small pendulum of length 1, this is 0.171 meter, 72 complete swings are the vibrations. This is vibration, and the swings are the trips in a time this much. What is the value of G? So G you have to find out. As I told you, G is equal to, we just finished 4 pi square L over T square. L is given, T you have to find out. Capital T time period is equal to total time, total number of vibrations. Time you have 60 seconds and the vibrations 72. 0.8, it's page 0.833 seconds. So G will be equal to T 9.73 meter per second square is your answer. So thank you very much. That is the last example of this chapter. Good luck.